Okay, so we are going to, in this video, look at special factoring. Special factoring can actually be found on your formula chart. They're kind of patterns or formulas that you can use to help you factor quickly. But you can always factor the original way, so don't worry about that. But this is just a pattern that we can see and notice. So let's start with our first one here. So when I look at this first one, I have x squared minus 49. And if I look at my formula chart, this is actually the difference of two squares. I have a square, and they're subtracting the difference of two squares. So by doing that, I can actually just find what would multiply to make each of these. So what would multiply to make my x squared? Well, x would. So I know that I'm going to have x, and I'm going to have x in my linear factors. And then what would multiply to make negative 49? Well, thinking that it's the difference of two squares also. This is a square, so I would have minus 7 and I have plus 7. Okay, so this is not a perfect square because these aren't the same dimensions. I have x minus 7 and x plus 7, but it's the difference of two squares. So very quickly, if I recognize this pattern, I can factor very quickly, noticing that these values are the same, just opposite of each other. So x minus 7, x plus 7. Okay, so now I can very quickly solve. So now I have x minus 7 equals 0, and x plus 7 equals 0. I'm going to add 7 to both sides. And I have x equals 7. And on this one, I'm going to subtract 7 from both sides. So I have x equals negative 7. So my solution is x equals 7 and negative 7, or you can write it negative 7 and 7. You also might see it as x equals plus or minus 7. So positive or negative 7. So we need to recognize that there's two ways to write this. Okay, so I want you to pause the video and try this next one that is also the difference of two squares, and then come back to the video once you have completed that. Okay, so looking at this next one, if it's the difference of two squares, I know I'm going to have x and 3x to make my 9x squared. And then to make my negative 5, I'll have plus 5 and minus 5. So now to solve, 3x plus 5 equals 0. I'll subtract 5 from both sides. I have 3x equals negative 5. I'll divide by 3 on both sides. So I have x equals negative 5/3. Okay, and now I'll have 3x minus 5. 3x minus 5 equals 0, so I'm going to solve again. I'm going to add 5 to both sides. I have 3x equals 5. I'll divide by 3. And I have x equals positive 5/3. So hopefully you're recognizing a pattern. Here it was 7 and negative 7. Here it's negative 5/3 and positive 5/3. So I can write this as x equals positive negative 5/3. Okay, so then looking at our other special case, I also have our perfect square trinomials. So to determine if it's a perfect square, I have a hard time looking at this formula, but I look at my first term, which is a perfect square, and at my last term, which is a perfect square, and I try to determine if this middle one can easily be divided into the same number, okay, so same coefficient. So this could be divided by 2 to be 10x and 10x. So that's one thing I look for first. And then I choose to kind of set it up so I can see that to make sure it really is a perfect square. So now I have x squared. This could be 10x. This could be 10x. And then if it is a perfect square, this should be x plus 10 and x plus 10. And this is 100. So it is a perfect square. It worked out. So I know that I have x plus 10 squared as my linear factors. So to solve, I'm going to set it equal to 0. Subtract 10 on both sides. And I have x equals negative 10. And that will be my only solution. So again, pause and try the next one. Okay, so looking at my next one, I can see my first is a perfect square, my last is a perfect square, and my middle can be divided up into negative 18 and negative 18. So trying that out, okay, I know that this will have to be 2x and 2x to make 4x squared. I know that this will have to be negative 9 to make the negative 18. And that would make this negative 9 times negative 9 is a positive 81. So it is a perfect square. So I have 2x minus 9 squared as my factors. And now I need to set that equal to 0. I'll add 9 to both sides. 2x equals 9, and I'll divide by 2. So my solution is 9 halves, or this one's an easy one to write as a decimal, 4.5. So x equals 4.5. So this is how we factor our special cases, or how we solve quadratics using our special factors.